Hello there, and welcome to this online lesson on calculations and negative numbers. Welcome to our lovely audience who is watching live. We have a few people here. If you want to say hello in the chat box to everyone, make the people watching the recorded version feel that they're not watching on their own. If you didn't watch my introduction to the course, please do watch that first. I explain things like how to set up your online textbook, how to work through the course materials, who your tutor is and things like that. And also I talk about the exams and how to book them. So watch that if you haven't done it already. It's on your main GCSE Maths course page. My name is Melissa Lieberman. If you haven't watched that already, just in case you think, who is that? I'm the in-house maths teacher at ICS Learn. It's me who will be delivering all of your online lessons throughout your studies. And you can call me in the office if you need help with things. There's my number there on the slide. I show this at the start of every live lesson. And there's my email address if you want to email me and ask me any questions about maths. You also have a tutor who you can contact for help as well. So I'm available during the day. Your tutor's generally available in the evening, so you've got plenty of people there if you need help with anything. Please don't be afraid to ask for help. It's a very important part of the learning process. So don't feel overwhelmed. I know it's difficult when you first start, especially if you haven't done maths for a long time, but we're very friendly here. No one's going to judge you, and we're here to help. So today I'm going to cover a few different things. We're going to do a couple of basic whole number calculations. Especially I'm going to do long multiplication. I'll show you two different methods, and I'm also going to do some short division. I'm not going to do long division. Please don't study long division because you won't need it in the exam. So there is a non-calculator paper, so you do need to be able to work things out using a pen and paper method without a calculator. But maths is not about doing hard sums, so please don't spend too long. I know a lot of people are a bit nervous about not being very good with arithmetic. I'm one of those people. Learn your times tables, it will be helpful, but beyond that, don't spend too long on working with numbers. Maths is much more about algebra, problem-solving skills, breaking things down step by step, presenting a written solution, and geometry and those kind of things. And anything that's important will be revisited again and again throughout the course materials. So don't spend too long on this section. This is my top advice. Just do bits and bobs. It should be revision of things you've done before. Nothing should be a completely new idea. Spend as much time as you need to, but no more than 5 hours, I would say, tops. You spent 5 hours, tick it off your list, move on to the next thing, but certainly not a week or 2 weeks because there's so much other things that you need to go through. So I can just see some things coming up in the chat box there, so I'm just going to change my view there because I haven't got a very good view of the chat box. I'm just going to close this panel. Oh, Demi, you're on a phone as well, and you're having difficulty. Not to worry. I'm not sure how the sound settings work on a phone. If you do come to the live sessions, I really advise people to use a PC or a laptop or a big tablet because mainly because you just won't be able to see all the little numbers on the slide. You need to have a good full screen view. Okay, so one thing I will say is as you watch these live lessons, even if you're watching the recorded version, make notes as you watch and write things down. Now, if you're watching the live lesson, you won't be able to write everything that's on every slide. So just make some brief notes, and if you need to go back and fill it in later, the beauty of these is you can watch the recording. So if you're in the classroom and the teacher's going too fast and you panic and you fall behind, this won't happen here because you can just watch it back later. So if you're a slow writer and you would rather just sit back and watch the lesson live and then watch the recording later on, you can do that obviously. Each of these lessons will last about an hour, and you might find if you're watching the recorded version that you need to break it down a little bit, pause it, break it up into smaller chunks. If that suits you, you can do that. And these recorded lessons will be available for the whole duration of your studies with ICS Learn, so that they're not going to disappear. They're there for the whole time that you're enrolled with us, and you can go back to them, you can go through them in a different order if you want to. They're there as a resource for you to use as you work through. If you're watching I'll just go through this very quickly. If you're watching the YouTube version of this, can I just ask you to view this in full screen mode? That way you'll be able to see all the little numbers as you go through. All of the links that I'm pasting in this chat box as I go through will be pasted into the box underneath the YouTube video. So click on the, make sure you're watching it in YouTube. click on the show more box underneath, and that will be all of the links that I give out during the session. Those of you watching the WebEx version, to access any links, because all the way through I put in some links that makes it a bit more interactive, you need to make sure you've got the chat box turned on. So click on view. Don't know if it's that way. No, probably pointing them away. Click on view at the top. Click on chat, and that will open up the chat box. And there's a little icon as well, so you might see a little icon like that. I think it goes red once someone's typed something into the chat box, so you can read back what's in it. And if you're watching the WebEx version, if you've used the link on the GCSE 9-to-1 Maths Lessons page, you can drag these windows out of the way. You can move the video to the top if it's in the way of the slides. You can turn the video off if you want. Even people watching live can move their panels a little bit, but we'll leave them where they are. I wouldn't advise doing that right now. This table of contents, if you're watching the WebEx recording again, and you don't want to watch the video of me talking if it's not important to you, you can turn off the video, cut out the sound, and just go through the slides using the table of contents. You can just literally click through the slides and just go through a slideshow in your own time, and you don't need to see me or hear me at all if that's the way you would rather work through it. So you can do that in the WebEx version. Okay. So before we start, I just want to make sure, in fact, those of you watching live can tell me, have you activated your online textbook yet, the Cambridge 9-to-1 textbook? I don't follow the textbook exactly in order during these lessons, but I think it's still a good idea to download it, use it for worked examples, use it for further explanations, and use it for exercises as you go through. Some students find it quite difficult, and it is. Even the foundation book is a bit more advanced in the exercises than a lot of the questions you would get in your GCSE maths. But it's good to stretch yourself. If you're really finding it too difficult, too challenging, too overwhelming, I'm going to give you some links at the end of this lesson for some alternative books that you can use. This one is very good as a source of questions. I'll give you a link to that on Amazon in a minute. To set up your textbook, you need to make sure that you go into your GCSE 9-to-1 maths course. So you have to scroll down from the home page on the ICS Learn Student Community, and then scroll down to where you see Student Course Resources. Click where you see this green jigsaw piece. That will, if you haven't set it up yet, that will allow you to set up the textbook account with an email and password. The answers to these books are here. So these are the instructions for setting up the textbook for the first time. The foundation tier book answers are in this top link, and then the higher tier answer book is in the bottom link. If you want to print out those answer books, it might be a good idea. Don't print out the textbooks because they're really massive, as I showed you in the introduction to the course. So print out the answers, and that way as you're working through, look at the answers as you work through, and that way you know that you're on the right track and you know that you're doing the right thing. If looking at the answer doesn't help you answer the question, whatever you're working on, ask your tutor and they'll be able to help you out. Just give them the page number, tell them whether it's the higher or the foundation tier book, and they'll be able to help you. Now, I don't know, the writing's very small, but if you open up the textbook, it will open on the foundation tier book by default. If you want to go to the higher tier book, there's a little instruction here. Click on the library or house icon. So there'll be a little house icon in the top left-hand corner, and that will take you to your bookshelf. I'm going to give you a link now, so I'm going to paste this into the chat box. Just give me a moment, I just need to open the document. Now, anything I paste into this chat box, any link that I paste into this chat box, will open up in a new window. So as you go through and I paste in links, you'll be able to do that. So let me just give you a link to the bookshelf. Give me a second. I should have opened that before I went live on it, but I won't be 2 seconds. Let me just pause a second. Okay, so here is the link to the bookshelf. If you save that to your favourites, you'll be able to go straight to the textbook bookshelf without logging into the ICS Learn Student Community first. So open that, and that way you will see both the higher and the foundation tier textbook. The books are virtually the same in a lot of areas, but the higher tier book will cover grade 6, 7, 8 and 9 topics that are not covered at foundation tier. So the higher tier book includes everything that's at foundation with some extra topics added in, and a lot of the exercises have got a few harder questions in. Okay, so we've got the book. If you want direct links to the answers, I can give you those here. So this is a link to the higher tier answer book and a link to the foundation tier answer book. And at the end of each lesson, although I don't follow the textbook in order, I'll tell you which exercises and which questions are most relevant to what I've just done. So there's links to the answer books. Save them somewhere safe. click on them and then save them somewhere safe. They're also on your course page if you can't find them later on. And I'm also going to give you, this might be quite helpful, a link to a study plan. Now, I know you have another study plan on the math lessons page, which has links to math lessons, but this study plan has just got a list of all the chapters in both textbooks and a direct link to those chapters within the textbook. So that might be quite handy to use if you just want to use the textbook to find some particular material. It might be easier than using the online book. Don't buy the book, it's really massive, and you've got a free online version included with your course materials. And you can print individual, don't print all of it, but you can print individual pages out if you want to take a couple of exercises on the train or on holiday with you, then you can print pages from the book. Okay. Let's get started. So that's what your bookshelf page looks like. So save that vital source link to your favourites. Now, I'm going to cover more or less the topics as they appear on your course page. So today I'm going to do calculations. They're not in these course materials because it's not. We assume that you can already do calculations, but mainly today this negative numbers section will be the most relevant. So when you finish working through this lesson, if you haven't done it yet, go to that negative numbers section. There's lots of videos on those pages, so they go into more detail. So if you're really struggling with negative numbers, do watch the videos on those pages in the Foundation 1 section. So Foundation 1 really focuses on kind of grade 1, 2, 3 kind of content. Next lesson, I will be covering squares, cubes, and roots, factors, multiples, and primes, but I'm just calling it properties of whole numbers. So I'll be covering this in 2 separate sessions. Okay, so let's have a quick talk about adding, subtracting, multiplying, and dividing. Should have a comma in there, really, shouldn't I? That's annoyed me now. I think I can. I'm proofreading A-level maths at the moment, so I'm getting quite good at spotting errors. So I should have a comma in it there. Tell me if you see any mistakes on my slides. Right. Now, in maths, we talk about operations. Now, it's not like in medical sciences when you're actually doing an operation on a person. An operation in maths is something that you do to numbers. So you can add them, you can subtract them, multiply them, divide them, square root them, find the reciprocal of them. We'll find out what that is at a later stage. You can find the sign of them and so on. So these are all kinds of operations. The 4 main operations that we use in arithmetic, you know these, I know, but I'm going to talk about different words that you might come across for these things. So what does that symbol mean? I know it seems really easy, and I'm not being patronising. I just want you to type into the chat box different words for that symbol, because sometimes the language is what makes maths difficult, and that sign symbol can mean lots of different things in different contexts in maths, and part of learning maths is how to understand and read the symbols. So we've got addition, we've got plus, we've got adding. What other ways could we use for adding 2 numbers together that you might see? So yeah, plus is the main one. I mean, if English isn't your first language, this is probably quite useful to know how we say maths in English. So some of the words that you might come across are these: addition, add, sum. So sum sounds a bit strange because we sometimes talk about a sum as just a problem in arithmetic, but it's actually a mathematical term. So if I say, what is the sum of 10 and 2, what I mean is that you have to add 10 and 2 together. So that's a very important one. If you're making notes, that's a very important one to make a note of, because the sum of 2 numbers actually means the 2 numbers added together. You'll see plus, you'll see total. What's the total of £5 and £7? That means add them together. You might also say increase 10 by 7, and that means add 7 onto 10. So that's some different ways that we might see plus, right? That might help you with the next one. Oh, I didn't mean to. I'll go back one in a second. I just showed you all the answers, so can you remember what you just saw? Different ways of saying this symbol here that we use quite a lot in arithmetic. Think of a word, pop it down. Minus, yeah. Now, minus is quite interesting. So it's a minus and subtract. They kind of both mean the same thing. Take away, perfect. I say take away quite a lot. It might sound a bit babyish, but when we say 20, take away 10, it means the same as subtract or minus. Another way that I'm going to use this minus sign is when you see a minus sign in front of a number to make it negative. So a minus in front of a 5. I know some people do say -5, but mathematically it should be read -5, and that means 5 below 0, and that's something that we'll be covering later on in the session. So yes, less, good. Maybe you saw it on the slide before I review. I think I put those 2 slides in the wrong order. I'll need to go back now. Okay, so yes, these are all different ways of saying subtract or take away. So that is subtraction, subtract, minus, less, difference. Difference is quite an important one. So if you're asked to find the difference between 2 numbers, it means you need to take them away. Decrease means go down or take away. So we've kind of got this idea in maths of a number line. We'll go back to it when we do negative numbers. Addition means go up the number line, and subtract means go down the number line. So we've got this idea of direction when we're adding and subtracting numbers. But basically, adding makes the number bigger, subtracting makes the numbers smaller. I know this seems obvious, but you know, it's important in maths to be really clear about what we're talking about. Take away, deduct, decrease, all words for this. How about this one? Whoops, no, went back to my slide. What does that one mean? It's not an X. Times, brilliant. Okay, so it means times, multiply, how many, lots of. I'll show you that. So we might also, this is a really, really important one. Make a note of this, product. When you're asked for the product of 2 numbers, it means you need to multiply them. So that's an important one to remember, because it might be one that you're not familiar with. So if I said to you, what is the product of 10 and 4? What I'm asking for you to do is multiply 10 and 4. So the product of 2 numbers means multiply them together. So times, lots of. So you talk about your times tables, and that means your multiplication tables, in which case we're just talking about whole numbers, one number, multiply how many lots of one number. And then the last one, of course, we've got this symbol here. This is, anyone? Divide. Thank you, Amelia. Well done. Amelia was very nervous at the start. I'm sure she's feeling a bit happier now that she knows what that sign is. There's a very important thing that I want to point out about this sign. Often in maths, when we set out a division, so supposing I wanted to write 20. Oh, I know this is a bit wobbly when I'm using my mouse. So supposing I wanted to write 20 divided by 5. I would often write it like this. Now, this is the more mathematical way of writing 20 divided by 5. So actually, a good way of thinking of it is that little dot there and that little dot there. They stand for numbers. And it might look like a fraction, and that's because it is, and that's because fraction means division. So when you have a fraction, 2/5, 2 over 5, it means the same as 2 divided by 5. And in fact, if you wanted to change the fraction 2/5 into a decimal, you would work out 2 divided by 5 on your calculator, or do it as a short division. So you would often see it set out like this, 2 over 5. So that's what that symbol means. The 2 dots above and below the line kind of stand for a number above and a number below, the number on the top divided by the number on the bottom. And we'll use this throughout the course, so get used to seeing it written in that way. Divide quotients, yes, brilliant. The word quotient isn't used very often, but it can come up. So if you were asked for the quotient of 2 numbers, that would mean that you need to divide them. Other words that you might use is goes into. So how many times does 5 go into 20? So 20 divided by 5, how many times does 5 go into 20? And you can think of it as a repeated subtraction. So if you started with 20, took away 5, take away 5, take away 5, take away 5. How many times can you take away 5 from 20? So that's another way of thinking of it. Division is probably the hardest of all of the 4 operations to do mentally. I'm not going to teach long division, as I said, because dividing by any number bigger than 10 in your head is just really hard. Even if you're doing multiplying going back the other way, it's not even always taught in schools, and it won't come up in your exam. So I know it's something that people find hard. Most people don't know how to long divide. Even if you asked, anyone, any person off the street, if they can long divide, they probably don't remember how to do it, which means it's not a very good method if you can't remember how to do it. You have got a calculator. And you'll only need to do short division, which is division by a single-digit number without a calculator. How many times? Yeah, how many times would be something like, how many times does 10 go into 80? Same way saying 80 divided by 10. Okay, so we've got some of the language of maths worked out, because often we'll have word problems. Now, often you'll have a problem to solve, but it won't actually tell you whether you need to add, subtract, multiply, divide, what operations you need to use. And that's very common in a maths exam or in a textbook. So the first thing is not to panic. I'm going to give you some advice for solving wordy problems. I'll give you an example as well. So the first point would be to read the question carefully. This advice, by the way, comes from the CGP revision guide. Kind of nicked it because I was in a hurry, but it's still good advice, and I'll show you where you can find more detailed advice in your textbook. So read the question very carefully. Work out what bits of maths you need to answer it. So you need to know, well, am I going to have to add, subtract, multiply, divide? Don't just do something random. It needs to make sense in the context of the question. It's a good idea to underline or use a highlighter pen to highlight all the information that you need in the question. So any numbers that you've been given, any of those words that might help you to work out whether you need to multiply or divide. So if you see deduct or something less than or how many times are those words that we just looked at, that will be a clue. So you're kind of translating the wordy question into mathematical symbols with numbers and symbols, and that's all. And you might not, sometimes you're given extra information that you don't need. If you look at any of the GCSE maths past papers, you'll see the kinds of questions that I'm talking about. And then you need to translate this written question into the maths. Now, often you'll need several steps. So very often you can't just look at the question and just get the answer straight away. You'll need to say, right, well, from the information I'll be given, I can work out this. From this, I can work out this. From this, I can work out this. And so much of maths will be like that. So it's really important when you're working out problems in maths to have a clear strategy of how you're going to set out your answers and work in a systematic way. This is one of the very important things that maths will teach you. So a lot of people say, why do I need this in real life? But I think the real key thing in maths is to help you to think in a very structured way, to break down a problem into small steps, solve each step one bit at a time to get to the final solution. So that's why having a method and writing out your solution is really important. Now, another very important point I want to make at the start of the course is that the method that you use, there's no one correct method often in maths. There's often lots of different ways of getting to the right answer. So don't feel that you have to use one particular method. So for example, I'm going to show you two methods for doing long multiplication, but there's probably about at least 5 or 6 or 7 different methods. You need to use the one that makes sense to you, that you're going to remember easily, and gets you the right answer. So the correct method for you is more important than having one particular method that you have to stick to. So you can be flexible with that and think it through in a way that makes sense to you. That's important. So here's an example of a wordy question. A water company has 2 different price plans for water usage. Very typical kind of question. Those of you that haven't done maths for a really long time and hated maths at school, you're probably thinking, I hated those kind of questions, but don't worry. So we've got 2 plans. Plan A, no fixed cost, and you just pay 23p per unit. And then we've got Plan B, fixed cost of £12, or sometimes called a standing charge or something like that. So they've got to pay £12 regardless of how much they use, and then they pay 11p per unit. So obviously it's going to vary depending on how many units they use. Does it tell us that? It says the household, yes, it does, uses 102 units of water in 1 month. Which price plan would be cheaper for this household in that particular month? So what you need to do to answer this question is you need to work out how much it's going to cost on Plan A. You need to work out how much it's going to cost on Plan B. And then you need to write a final conclusion to say which one is cheaper. You can't just, if you just wrote down Plan A, if you just guessed, thought, well, I've got a 50-50 chance here, I'll just write Plan A, or I'll just write Plan B, and I've got a 50-50 chance of getting it right. That will not work. You will get 0 marks. So in questions like this in the exam, you really need to do the calculation, otherwise you won't get any marks at all. You can't just guess. Oh, Ahmed, don't worry if you're running a little bit late. Now, the first thing we would do is highlight the key information. It's already underlined. So first of all, Plan A, I'm just going to put my big fat highlighter tool, no fixed cost. So no fixed cost, and then 23p a unit. And they use 102 units. So how are we going to work out how much Plan A costs? Type it in the chat box, and then we'll look at the calculation. So we'll work that out first. So and it's helpful to, you don't want to write things down in maths, but it's helpful to write down what you're working out. So first of all, we're working out the cost of Plan A. Just tell me the calculation. You don't need to tell me the answer because we're going to use a calculator anyway. So cost with Plan A 102 units, 23p per unit. Thank you, Iman. You can write extra times as well. No, yeah, I mean, you can either do 0.23 times 102. That will give me the price in pounds. So be careful about units as well. Or you can just do 102 times 23 and convert it to pounds afterwards. So that's a good point. When working with pounds and pence, if you're not based in the UK, there's 100 pence in a pound, so 0.23 would be the number of pounds. So cost for Plan A, just write down 102. We can write it in pounds as a pound sign 0.23, or just write it as 23. That will give you the answer in pence, but then you need to remember to divide by 100. Use a calculator, because, I mean, you could work it out without a calculator, I think, actually quite easily. What I would do, I wouldn't do a long multiplication or anything like that. I would do 100 times 23p, which is £2.30, and then 2 times 23, 46, and add that on. I've lost track already, so you can just use a calculator as well. It might, something like this might come up on a non-calculator paper. So 102 times 23, have you got it yet? Let's have a look. £23.46. Rob, you got that? Good. Amelia? No, don't worry. Nothing wrong. So Plan A is going to cost £23.46. Next, how much is Plan B going to cost? So now Plan B is a little bit different because we've got this fixed cost, 12. So we're going to have to add that on. So we've got some adding. And then we've got 11p per unit. Now, per is a very important word to look out for in maths. Usually means that we're going to have to multiply something. So 11p per unit means 11p multiplied by the number of units. So that's a clue as to how you're going to have to work it out. And the cost per unit is, the number of units is 102. So in the chat box, please, what calculation am I going to have to do to work out the cost with Plan B? So Rob is saying 102, which is the number of units, times 11. Yep. Plus 12. Perfect. Good. That will give me the right answer, yes. Or you could just do 12 plus 11 times 102. It doesn't matter what order those two go in. Now, this is something called order of operations, or BODMAS, which I'm going to go through at the end of this session, just because it comes up a lot in calculations where you've got several steps. Or you can just use brackets. Just to be clear, use brackets like this. So we've got 12 plus 102 times 11p, or 0.11 if you're writing it in pounds. Or you can do it the other way around as and Iman, yes, you're right. You can maybe do that mentally, or just use a calculator if you're using the calculator. And you don't actually have to put the brackets in, because multiplication, if you've done order of operations before, always comes before plus. So put it on your calculator, or if it's on a non-calculator paper, find some quick and easy way of doing it in your head. Now, to multiply by 102, multiply by 100, so move the decimal point 2 places to get 1.10, and then double it, and then add that on, and then add on 12. So you can write it out in any way. You don't have to do any particular method. So just write out the way you would do it. So I would do 100 times 11p, and then I would do 2 times 11p, add it on, then add the 12, and you'll get there. The only thing you have to be a bit careful of is whether you're doing everything in pounds or everything in pence. Try to be consistent with units. So the answer we get is 23.22, and we want to know, I mean, I suppose this is another keyword, we want to know which one is cheaper. And you must put an answer. So if you just put both these figures, although you've done all of the work and the calculations, you haven't written a final conclusion, so you wouldn't get full marks. A question like this would typically be worth about 3 marks. So you have to put a final stage with the answer at the end. So which one is cheaper? Rob and Iman, you agree? Let's have a look. For this household, Plan B would be cheaper. Okay, so we've got quite a lot of work to do there, but it's worth practicing these kind of wordy problems. I'm not going to do any more examples today. Oh, sorry, I've just put some extra slides in, but they're not there now. I hope it saved my most recent version of this. Let me just check. I expected there to be another slide there because I added some examples for you to look at. So let me just check this. Not to worry. So what I'd like you to do, I haven't got the slide in, but that's not important. What I'd like you to do, let me just check. I'm going to just let me pause a second. I was in a hurry to get started. Let me just pause. Okay, so when you are doing your math exam, you will have 2 calculator papers where you can use a calculator, and 1 non-calculator paper. And there are 2 main arithmetic methods that you need to be able to use. not long division, but yes, short division, and also long multiplication. Now, long multiplication is when you have to multiply a 2-digit number or bigger by a 3-digit number or above. So I suppose this question we looked at here, we could have used some long multiplication, but I think key with maths is to use the simplest method. If it's easy numbers that you can work with in your head, so for example, multiplying by 102, just multiply by 100, multiply by 2, and put the two bits together. There's no need to use long multiplication for a question like that. So you don't always have to set it out in the traditional method, but it is something that will probably come up on a non-calculated paper, and it's something that sometimes people forget. So I'm going to show you 2 ways to do a long multiplication. I'm going to show you the traditional way that you probably learned when you were at school, if you're not at school anymore, and the grid method, which is also a really good method that is often used to teach young children how to do long multiplication in primary school. Loads of other methods. There's a method called Napier's bones. There's a Chinese lattice method. There's Russian multiplication. So when you have to do a multiplication like this, use the method that suits you the best. So we'll go through both methods here. You can make notes as you watch. I'm just going to do one sum in 2 different ways, but it probably will take me a little while to go through it. So here we want to work out 387 times 54. Now, what we normally do is multiply by the bigger number by the smaller number. So the smaller number in this case is 54. And you need to think of 54 as having 2 parts, the 5, which stands for 50, and the 4. So that 5 in that position, and we'll do more about place value later on, means 50. So what we need to do in this method is we're going to multiply. Hopefully you know how to work out short multiplication, but it should become clear. It should come back to you with some practice. So we're going to multiply 387 by 4. Then we're going to multiply 387 by 50. So you put a 0 and then put 0 to multiply by 10, and then just multiply by 5. Add those 2 together, and that will give you your total. So set it out like this, with the 54 underneath. The smaller number goes underneath. Has anyone never done long multiplication before? Hopefully this is revision, so make sure the numbers are lined up. You don't normally write them across the top, but make sure that the units are here. These are your tens, and these are your hundreds. So make sure that those are all nicely lined up. And then we work from right to left. So in the opposite way. So the first thing we're going to do, Rob, have you got a calculator, or did you work it out using long multiplication? You're not allowed a calculator for this bit. Maybe you just I'm not very good at arithmetic, so we're going to go through it step by step. Is that the answer? Let's see. Okay. So the first step is to multiply 4 by 7 on paper. Well done. You already know this. You can just skip to the end of this lesson and move on. Maybe you can go right to the end of Unit 1 if you know all this. Do the Unit 1 test and move on. These are the basics for new people just starting. But tell me what 4 times 7 is anyway. That's our first step. So we're going to multiply the smallest digit, or I don't mean the smallest digit, but the units in 54 by the units in 387. Thank you, 28. Now, 8 goes in the units column and 20 goes in the tens column, so we need to write 8, carry 2. So we do that first. So I usually put the 2 underneath like that. I don't put it with the number because then it gets mixed up with the next number. The next step will be to multiply. So we'll write 8, carry 2, that's the 28. Next step is to multiply 4 by 8. Bunnies, don't worry about being late. I'll send you a link to the recording afterwards. 32, thank you. So 8 times 4 is 32. And then you need to add the 2. Let me just put my highlighter pen underneath that. I put everything in blue, but just to be clear. So we do 8 times 4, and then we add in the 2. So we've got 32 plus 2, 34. Good. Rob, you're very fast, but don't worry if you're not as fast as Rob. We also have one show off in the class who's much quicker than all the others, but I'm not assuming that everyone can do this and finds it easy. So write down the 4, carry the 3, because the 3 is in the tens position, so we move that on to the next bit. Then we need to do 4 times 3. So we're just going to do digit by digit. 4 times 3 is, I'll keep my eye. I might do it wrong. I'm not very good with them. Much better with algebra. As I said, my arithmetics. I can't hold numbers in my head. I don't know why. It's probably a bit of a failing in a maths teacher. I'm much better than I used to be. Years of teaching maths means I know at least think I know most of my times tables by now. Perfect. Right. So 4 times 3 is 12, and then add the 3 underneath, 15. 5, carry 1, but there's nothing in the next column, so we just write the 1 down there as 15. So that number there, 1,548, is 4 times 387. The next step is to work out 50 times 387. Now, to work out 50 times a number, we just put a 0. That does all the taking care of timesing it by 10, and then times it by 5. So multiplying by 10 and then multiplying by 5 is the same as multiplying by 50. So in the next row underneath, and I've written that there in the box, just for people that are using the slides and not listening to my explanation. So this is 387 times 4. So put a 0, that's the first step for multiplying by 50. And then we just go through this time multiplying by the 5. Now they're a little bit misaligned this time, so make sure you keep everything nice and neat and lined up. If you want to do it in squared paper, that might be easier. So 5 times 7. And this time it's moved along 1 because we've got the 0 there. 35, thank you. So 5 times 7 is 35. Amount of 40, 15. 5 times 7 is definitely 35. So write 5 and carry 3. Next, 5 times 8. Oh, you're doing the next bit, that's probably why. But then remember that you need to add the 3. So we're going to do 5 times 8 plus the 3 that we carried. Thank you, Amanda. 43. So 3, carry 4. Put the 3, carry the 4 to the next column. And then the last step, at last, I hate these multiplications, 5 times 3 is 15, plus the 4 that you carried, 19. Sue, perfect, thank you, 19,350. Good. That's not the answer. To get the final answer, we need to add those two together. So this bit is, oh, yellow's a terrible colour there. So this number here is 4 times the number, just to remind us of what we're doing. This bit here is 50 times the number at the top. And so to get the whole thing, we need to add these both together. I'll just go through, I'm not doing addition and subtraction in this webinar because I assume that everyone can do it. We go through left to right, adding column by column. So the first bit is easy. 8 plus 0 is 8. 4 plus 5 is 9. We can all do this. 5 plus 3 is 8 again. Now here we need to carry, so we've got 9 plus 1 is 10, so 0, carry 1, and then 1 plus 1 is 2. And I think we've got to the answer that I think it was Rob said all the way at the beginning. There we go, 20,898. Everyone happy with that method? I can go away. It's good to have a refresh, it is, because if you haven't done it in ages, and everyone uses calculators nowadays, you probably will have to do a long multiplication in the exam, so it's a good idea to refresh yourself. I'm now going to show you the grid method. Now, if you went to school a long time ago, you might have never met this, but it's a really nice method. You get the same answer as long multiplication, but it just breaks the numbers up a bit more. So the way this works is we partition these numbers into, it's just a way of breaking it up. So remember, 387 means 380 and 7. That's what that means. It's like 3 numbers all scrunched together. And 54 means 50 and 4. So we can write them like that. So 387 is 300 plus 80 plus. There's another word for plus, and 387. 387. 54 is 50 and 4. And then what we're going to do is we're going to multiply every number in the 387 by every number in the 50 and the 4. So we're going to do 300 times 50, 300 times 4, 80 times 50, 80 times 4, 7 times 50, 7 times 4, we get 6 different numbers, we add them all together. Now that sounds a little bit complicated, but we just put it in a grid and it makes it really easy, like this. Okay, so there's our grid. Now, 354, I mean, it doesn't matter if you put the smaller number at the top, usually it's better to have a longer grid. So 387, and then here 54. And then what we do, I haven't written the multiplication symbol in, but you can if you want, is we're going to multiply so for each box, we're going to multiply the start of the row by the top of the column. You only actually need to multiply together the non-zero parts. So for example, 5 times 3 is 15, and then count the zeros. So 15, and then 1, 2, 3 zeros, and that goes in that first box there. Okay, now I've written this in blue, but normally you wouldn't write that down. You would just do 50 times 300 in your head. So 50 times 300, answers quickly in the box, and then I'll reveal it. So you do 5 times 3, 15, and then 3 zeros, because that's the number of zeros in the question. Like that, 15,000. Okay, let's just go along the rows like this. So next we want to work out 80 times 50. And be a little bit careful here because there is a 0 in 80 times 50, 8 times 5. So 8 times 5 is 40. And then we've got 2 zeros. You need 40 and then another 2 zeros. Perfect, Iman. Very quick. 4,000. So we put that in the next box, 4,000. This last box here, we want to work out 7 times 50. So that's the same as 7 times 5 and another 0 on the end, 350. That's a little bit more bitty, but some people find this box method much easier to remember. Then we do the next row, and we're just going to do 4 times 300. 4 times 3 is 12. You do need to know your times tables. Only up to 10 times 10. 4 times 3 is 12, and then 2 zeros. 1,200. Thank you, Iman. Good. And that's the next one. Don't be too fast because I'll get mixed up because I won't know which bit you're answering. The next box, 4 times 8, 32. Plus a 0, 320. And then the last one, just 4 times 7, 28. Now, if you want to do it bit by bit, what you could do to get the answers, so basically all you're going to do is add together all these numbers in the boxes. But you could just go through, you could add these two and put the answer there, you could add these two and put the answer there, and you could add these two and put the answer there, and then add those three together. I'm just going to write them in a big long list. Because there's lots of zeros in there, they're easy to add together. So I'm going to work out, let me just put, I have my highlighter, so I'm just going to work out 15,000 plus 4,000 plus 350 plus 1,200 plus 320 plus 28. And we get a grand total of, surprise, surprise, that number looks very familiar, 20,898, which is the same answer we got before. Those of you watching live, quickly, which method do you prefer, A or B? Where A is the traditional method and B is the grid method. What would you rather do? Iman, you'd rather do the normal one. You'd all rather do the traditional one. I know loads of people that prefer the grid method, and so I'm glad I showed it to you because it's nice just to have an alternative. And those of you that met the grid method and used it a lot when they were at school, maybe it's one that you're less familiar with. Yeah. I mean, I think people stick to what they're used to, but this is a good method as well if you want to try something different. You might, if you want to challenge yourself, you might want to try doing some questions using this grid method just to see a different way of doing things. Now, I'm going to go through quickly the method for short division as well. Short division is just dividing by a single digit number. You do need to know how to divide by a single digit number without using a calculator, but you don't need to know how to divide a 2-digit number without using a calculator. I think some of the questions in the textbook do involve that. Try them if you want, if you can remember how to do long division, but don't worry about it because it won't come up in GCSE. Anything that's a really complex bit of arithmetic that you can't do just using normal times tables and place value facts will be on the calculator paper. In fact, if you do IGCSE maths, there is no non-calculator paper. You do 2 papers, both use a calculator, and more, you know, people are using calculators. And now A-level maths, all the exam papers use a calculator. There's no need for any arithmetic at all. Everything is done with a calculator, and I think things are going more and more that way. So where in the past it was 50-50 calculator, non-calculator, now it's only 1/3 non-calculator. So if you're not very good at arithmetic, that's good news. You can just use your handy calculator, which is never far away from me because I'm very lazy at doing arithmetic. I don't like doing it at all. So here's our sum. Work out 3,144 divided by 8. Now I'm going to do this as a long division, but there's a way of simplifying this problem, of making it a bit easier. I'm just going to show you this because it's quite a good trick to know. It's not really a trick, it just uses fractions. So let me just show you this. A way of simplifying this might be to write it as a fraction like I showed you earlier on. I've just thought of this moment, so I'm ad-libbing a little bit. If you wrote it as 3,144 divided by 8 like this, and they say, okay, I'm going to cancel this out. I'm going to divide top and bottom by 2, and I just have to top and bottom. Now you need to be able to divide 3,144 by 2. Sorry, I'm not using a calculator here. I'm just going to work it out in my head. You can do it in your head, but I just don't want to make a mistake while I'm on a webinar. I don't want to mention again how bad I am. So, and that would be I'm going somewhere with this 1572. Because it's quite easy to have things in your head without using a calculator, isn't it? Yes. Yes, miss it is, divided by 4. That's exactly the same. That's exactly the same sum. 1,572 divided by 4 is exactly the same as 3,144 divided by 8. So this is a really good way of simplifying a division. If both numbers are even numbers, you just divide them both by 2. And then you could just divide that by 2 in your head, not using a calculator. 786. You can't see the calculator here off the webcam, so you can just pretend that I'm doing this mentally. Divided by 2. And actually, you would get to the answer because that's just divisible by 8, and you could just do it that way and just keep divided by 2. It doesn't always work, but for this particular question, I just spotted that that did do that, and then divide that by 2. What do we get? Divide that by 2 in your head, 393. So that would be one way of working it out. So just to say that very often in maths, so that's over 1, which just means that that is the answer. So very often in maths, there's more than one way of working something out. So it's always good to spot things and think, all right, well, I could do it that way. So if you find it easy to just divide things by 2, you could do it like that. But anyway, the whole point of this question was to show you short division. So to set it out in the traditional short division way, what you would do, I'm just going to rub all of this out. I was doing it slowly. I'm going to change to a nicer blue pen. You would write the 8. I don't know if that's the pen or the pencil. So you would write the 8, which is the thing that you're dividing by on the outside. And then normally you do a nice square thing like this. And then you do 3, 1, 4, 4. And we work from left to right, dividing the digit that we're divided by into each digit in the short multiplication. So let me just set this out nice and neatly like that. So the first step is to say, how many times does 8 go into 3, or 3 divided by 8? It doesn't go into 3 at all because 3 is smaller than 8, so put a 0. You don't have to put a 0 because normally we don't put zeros at the start of numbers unless they're decimals, and we'll go on to decimal calculations in lesson 6, I think. So 3 into 8, 8 into 3 doesn't go, so we put a 0 like that. And then we carry the 3 to the next column, so it acts like 30 in 31. So we carry the 3 like that. Whoops, I think I did too many steps. So we carry the 3 into 31. So we put the little 3 there if you want. Now, I think I've shown too many steps there really. Let's just go back a step and see what we did there. 8 into 31. So you need to remember your 8 times table. So you can use your fingers if you want. I'm all for that. So we've got 8, 1, and then second finger, so 8, 16, 24, 32. So it goes 3 times. 3 times 8 is 24. 31, take away 24 is 7, so the remainder is 7. So you need to put, it goes 3 times, 7 left over, carry the 7 to the next column to give us 74. Then we need to work out 74 divided by 8. What's 74 divided by 8? Well, you need to go to your 8 times table again. A shortcut might be is to say, well, I know that 10 times 8 is 80. 74 is very close to 80. So I've got 80. If I go down 8, that takes me to 72. So 9 times 8 is 72. I don't know my times tables either. I just work it out that way. So it goes 9 times. 9 times 8 is 72. Remainder 2. Is that okay? Following this, division is quite hard to do mentally. You need to know your times tables really well. 74 divided by 8 is 9, remainder 2. Because 9 times 8 is 72 and then 2 left over. So then we need to do 8 into 24. 24 divided by 8, we did it a minute ago with our fingers, is 3. So there we go, we put that 2 on there, and then we put 24 divided by 8 is 3. So the answer is 393. We don't need to have the 0 at the start. So which method do you prefer? Using the fractions and halving the numbers until you get to the answer, or doing a short division like this? A is the one I showed you first with the fractions, and B is short division. Which one do you prefer? Yeah. Probably, again, you're preferring the traditional method, but that's fine. One example of where this reducing fractions is very useful, and you'll have to use it is when you're dividing decimals, because it's really almost impossible to divide by decimal numbers. So we'll need to convert them into fractions and then use place value to kind of jiggle them around a bit. So we will need to use that method at some point in this course for certain examples. So remember it, and we'll revisit it later on. But if you like short division, that's the one that you'll use, and there will be some kind of short division in the exam most probably. The hardest thing is knowing what to do when there are remainders. Now this lesson is just about whole numbers, so I'm not going to deal with remainders right now, but anything that's important will be revisited again and again. So we'll go back to what to do with remainders, whether to write them as decimals, whether to write them as fractions, whether to interpret them in different ways. So the division is something that where the remainder, the bit left over at the end, there's different ways that you can treat that, and we'll go on to that in a later lesson. Okay, so if you want some practice of some arithmetic questions, have a look at exercise 1A in your book on page 5. I'm going to give you a direct link to that page. If you're watching the recording, you can stop now if you want, or go straight on to negative numbers, which I'm going on to next. So here is, I'm going to link to both exercise 1As in both the higher tier and the foundation tier book. They're almost identical. Have a look at them. Now, I think that some of these questions are in here. It does say using written method, but that probably makes a lot of these unnecessarily complicated. If you've got lots of time and you really want to be good at arithmetic, you can do these if you want, but life's too short. Do at least the first 2 questions without a calculator, and then if you want to use a calculator, you can, because what I think is more important is to know what operations you should be using, whether to add, subtract, multiply, and divide, and your calculator will not make that decision for you. So answering these questions with a calculator is not cheating, in my opinion, because you still need to know what it is that you need to put into your calculator to get the answer. So with these wordy problems, translate them into numbers and symbols. Put the number in your calculator if you wish, and if you want to, I'm going to allow you to use a calculator. So try those exercise 1A just for some wordy arithmetic problems. See how you get on. Check your answers as you go through. As I said, you can do 1A in the foundation tier book, or you can do 1A in the higher tier book. They're practically the same. Now, if you want to have a look at the kind of arithmetic that you'll need to be able to do on non-calculator exam papers, I would really advise having a look at some 1F or 1H papers. Go to the, I'm going to give you a link here in the box again. So hopefully your chat box is open. If you're watching the YouTube version, remember you just use the link underneath the video. I don't think I saved the link, but the way you get to these mock exam papers, go onto your main GCSE Maths course page, click on exam discussion, and then at the top of the discussion list is links to mock exam papers, and have a look at the written. I mean, I'm not asking you to work through any exam papers at this stage, but I think it's a good idea to look at them right from the start so that you're aware of the types of questions that you're going to have to answer in the exam. Have a look at the written solutions, and that will give you a very good idea of what proportion of the questions in your final exam are going to be arithmetic style questions. Yes, of course. So Sue, when you watch the WebEx version of this recording, just send me an email if you can't find the link. This chat is saved, so you can use all of the links that I put into the box will be saved along with the presentation. Or if you can't find it, send me an email and I'll just cut and paste it and send it over to you. Okay, so it's all captured in the recording. Let's go on to negative numbers. Now, negative numbers are really important in maths. Now I'm kind of saying, don't worry too much about long division, but negative numbers you can't skip out. A lot of people struggle with them at first, and one thing I will say is do your best with it. If you find it hard, don't worry, because there'll be lots of opportunity to come back to this topic, because it's something that you'll be using all the way throughout your studies of GCSE math. It comes up in algebra all the time, in substitution. It comes up in graphs, and when you're substituting values into graphs, it comes up in sequences when you're doing sequences of numbers. So it's something that you'll see quite a lot as you work through the course. And in fact, these kind of negative number sums that you get at the beginning of course, like -5 plus -8, you probably won't be asked to answer something like that in the exam. Might be in the context of temperatures, but it's important that you understand how negative numbers work and what we mean. So let's talk about what something like this means. Now, I normally read this as -5. I try to. Sometimes I say -5, but really, strictly mathematically speaking, it should be -5. That doesn't mean subtract 5. So there's a difference. This minus symbol can be used in two different ways. It can be used to mean take something away, and it can also be used to indicate that a number is negative. So one is using it in a describing way, and one is using it in an operation way. And this means 5 less than 0. So think of temperatures. If it was freezing, if it was 0 degrees, and the temperature went down 5 degrees, that would be -5 degrees, -5. Now, it often helps when you're starting out to draw a number line. With practice, you shouldn't draw a number line. You can just imagine it. If you're really stuck in the exam and it helps you, do draw a number line. That way you can see the relative positions of all of these on the line. And we've got 0 in the middle. These are all whole numbers, by the way, so they're called integers. Have you heard that word? Integer is just a whole number which can be positive or negative or 0. So we've got 0 in the middle. And then we've got numbers that are bigger than 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then numbers that are less than 0, -1, -2, -3, -4, and so on, going that way. When you start working with coordinate axes, this is how you'll label the horizontal axis, and then the vertical axis will be the other way around, so you have 0 in the middle, going up, positive, down, negative. And negative numbers are often called directed numbers because we've got this idea of direction. Positive goes up the number line from left to right, and negative goes down the number line from right to left. So that's when you're saying right to left. So these are our negative integers. So -1, -2, -3, -4. So this minus sign in front of the number just tells me that the number is negative as it's below 0. I'm not subtracting anything. But I suppose you could kind of think of it as 1 subtract 4, depending on how it's written, but it's telling me that that's -4. So sometimes you will see brackets around these like this. And that is just holding sort of making the minus sign stick to the number. So this means -2, this means -7, and so on. Now on this number line I've got integers, but you can have any number on this line. There's infinitely many numbers between 0 and -10. So I could have this number here, halfway between -8 and -9 would be -8.5. So you can have decimals, you can have fractions, they can be negative as well. They're not integers, but just to say so that you don't think that we're leaving them out, you can have any number with a minus sign in front of it. Now, the word integer will come up, so make sure that you learn it and that you're familiar with it. Integer means specifically a whole number, positive or negative. Okay. So let's have a couple of sums and see what this means. So here's 2 questions. If you want to have a go at answering them, feel free. So anything with a decimal point is non-integer, yes, right. So if it's got a decimal point, if it's got a fraction in it, if it's an irrational number, like pi, that's not an integer. Integers have to be whole numbers. So when we're talking about it, somebody said to you, write down all the integers between -3 and 5, you would just write -2, -1, 0, 1, 2, 3, 4. You wouldn't write down the decimals and the fractions in between, because integers are strictly whole numbers. Good. Right, work these out. So what does this mean? So we've got -2 plus 7. And what that means is you start at -2 and you go up 7. It does make sense to think of these in context of temperatures for some people. So if you think it's -2 degrees and then the temperature increases by 7, we're going to go up 1, takes us to -1, up another 1 takes us to 0. So when we go up 2, that takes us to 0. Then we need to go up another 5, so it will take us to 5. So let's have a look at these on the number line though, so that we can see how they work out. And then part B, -4, subtract 5, so that means go down the number line 5 places, and then add 3, and then go back up again. So let's see what this looks like on a number line. Here we go. So the first number in the question, so in this example -2, is our start point. So that means we start at -2. And then the add 7 means go 7 spaces up the number line. You can think of this in 2 parts if you prefer. So we've got -2, you need to add 2 to get to 0. And then you need to add another 5 to add on 7 altogether. So the answer is 5. So 5 is your finishing point. Is that okay? There's some much more detailed examples of working with negative numbers on a number line on your GCSE 9-1 maths course page. If you go to the first section, whole numbers. In the negative number section, I put a whole load of really detailed video examples on there so that you can practice that. So yes, that's it. Start at -2, count to 7 places, up the number line, and you get to 5. Right, how about part B? I'm seeing a few people. Bernice, was that the answer to A or B? -6. Well, let's see. So again, the first number is the start point. So we start at -4. I'm just going to use the same number line again. Start at -4. And then I'm just looking at the time. I'm always overrun with this webinar, but it's an important one. So people watching live, if you feel that you need to go, I'm always at the 1 hour mark. You can if you want. So start at -4. Then subtract 5. So we start at -4 and we're going to go 5 down the number line, like that. That takes us to -9, but we're only part way through because then we've got add 3. So we go down 5, that takes us to -9. And then we need to go back up 3 again. I know I'm doing this and this, but you're probably watching a mirror image of what my hands are doing. I'm looking at the number line, so you're seeing it the other way around. So when you add 3, you go 3 up from 9, takes us to -6. So that is the finishing point. That is our answer. Okay, so if you need to use a number line to help you with the visualization when you first start, then do that. But these are often called directed numbers or directed number arithmetic because the first number tells us where to start, adding takes us up, subtracting takes us down. And that's all it is, up or down. Now, where some complication may come is when we see a combination of adding and subtracting in brackets like this. So if I have a calculation that says 20 subtract -17 like this, we're using the minus sign in 2 different ways. So this means subtract or take away, that's an operation. And this is telling us that this is -17. And when we subtract a negative number, those 2 minus signs if I subtracted 17, I would go 17 down the number line. But if I subtracted -17, I'd have to go up the number line. So subtracting a negative number is the same as adding. That's really the only one that you really have to remember that's a bit odd. Any other ones is actually quite easy, it makes sense. So for example, if we had 200 plus -500, the plus means add, and the -500 means that we effectively take 500 away from 200. We need to go down the number line. So when we see, when we take away a negative number, that's the same as adding. When we add a negative number, that's the same as subtracting. But those signs have a different function, which is where I think confusion comes in sometimes. So one is the operation, add or subtract, and one is the sign of the number, so -7 or +7. If you see a plus, now if it's +7, if it's +7, you don't normally write a plus in front of it, but sometimes just for clarification you might see that, so don't worry about it too much. So we need the minus sign if it's a negative number, because otherwise we don't know. If there's no sign, it means it's positive. If there's a sign, then it's negative. Okay, so I'm not actually going to go through these calculations. I just wanted to clarify that point of, why when we have these signs, how they combine to make a single sign. So this means add -500. So let's have a look at a couple of questions where these brackets are in. So the thing you need to remember with adding and subtracting is if you see a plus next to a minus, that means subtract. And if you see a minus next to a minus, that means add, because if we subtract a negative number, if we subtract the positive number, we go down, but if we subtract the negative number, then we go back up again. There's actually a really good explanation of adding and subtracting positive and negative numbers. I'm going to give you a link here. It's called Math is Fun, math spelled in the American way, adding, subtracting. They've got some really good analogies and diagrams, and I really do advise, if you're watching live just now, you can just click on this link and it'll open up in a new window. Have a look at that. So there's some really nice pictures to explain these, because you can get muddled when you first start. So here's some examples with brackets. So the first question says 7 take away -5. So this first minus sign is telling us to subtract. And this minus sign is telling us that the 5 is negative. So we're subtracting -5. The next question, if you're watching the recording, you might want to pause and try these yourself first before I go through the solution, is -4. So that's just our starter point in the number line, plus -9. So this means that we're adding, so this is the operation. And this is telling us that this is a negative number. So that's the same as -4 subtract 9. So you can combine those two signs, maybe take away the brackets first, and then the brackets are just to tell us that a minus sign is attached to that number. So that's how I would do it. So the first step, do it in a few steps. So you've got 7 minus negative 5. Get rid of the brackets. So 7 minus negative 5 like that. It looks a little bit less clear, but because you've got two negative signs next to each other, it's equivalent to adding. So actually write it down as 7 plus 5. 7 plus 5. That's the hard bit is done. The next bit is easy peasy, 12. So that's our answer. You can test it on your calculator. Use this, so I don't know if you can see here, but if you've got this calculator, there's a little minus in brackets, and that's what you need to use. So you need to type in 7 minus, then this little minus sign in brackets there, because that means negative, so negative 5 equals, and you've got 12 on there. So I don't know if you can see that in the webcam, but do try it on your calculator. Make sure you use that little minus in brackets there to work these out. So please use your calculator throughout the course. It's not cheating. It's a good way of checking your answer. You go through it even when you're doing arithmetic like this. So part B, so we start at -4, and then we're adding -9. So first step, drop the brackets. We've got a plus and a minus next to each other. If you've got a plus and a minus or a minus and a plus, it's just minus, it's just take away. So subtract -4, subtract 9, start at -4, go down another 9. What do we get? So if it's -4 degrees and it goes down another 9 degrees, what will the new temperature be? -13. Anyone else? Do you agree with that? So if it's -4 and we go down another 9, well, 4 plus 9 is 13. If they're both minus, it will just get even more minus. So perfect, -13. Good. Okay, that's it for adding and subtracting. Now, people get mixed up with this sometimes. When you add and subtract negative and positive numbers, you don't know what sign the answer is going to be. You can't tell by looking at the numbers because it depends on the starting point, depends how much is added, depends how much is subtracted. However, with multiplying and dividing, it's a little bit more straightforward. There's two steps. First of all, decide what sign the answer is going to be, if it's going to be positive or negative, and then just multiply the numbers or divide the numbers. So it works a little bit differently. So let's look at a few examples. Now, when we multiply or divide two numbers with the same sign, the answer will be positive. So if both numbers, it might involve more than two numbers, but we'll look at examples like that in a minute. So if both numbers are positive, then we've got the same sign. If both numbers are positive, then the answer is positive. If both numbers are negative, then the negatives kind of cancel each other out, and that gives you a positive answer. I'll summarise these a bit more in a minute. So for example, if you have -4 times -2, the minus signs cancel each other out and the answer is positive. So a minus always changes the sign of the thing following it. So we've got a negative times a negative will give a positive answer. And then you just multiply the two numbers together. So if I've got a minus and a minus, the answer will be positive. 4 times 2 is 8. You meant 8. I was wondering why you put -8 there. So the answer is just 8. And similarly with division, if we have -4 divided by -2, it's a little bit clearer if you write it like this in the fraction format, because these negatives just cancel out. And then we've got 4 divided by 2, which gives us just 2, no sign in front. If the signs are different, if it's two numbers with a different sign, then the answer will be negative. So if we have 4 times -2, that will be, Iman was right a minute ago if he had seen into the future and seen what that would be. So 4 times -2 is -8. And -4 divided by 2, the signs are different, so the answer is negative. And then 4 divided by 2 is 2, so we've got -2 there. Okay, let's have a few examples. I've just got two numbers here, so have a quick think about this. So the first step, part A, is it going to be positive or negative? Well, the signs are the same. Negative number times a negative number is a positive number. These are just rules that you will need to remember. So the answer is going to be positive, and then we need to work out 7 times 6. That's just your times tables. I can't remember. 3 times 7 is 21, so 6 times 7 is 42. So it's going to be positive. Good, Bernice. So we multiply those together, so we get plus 42. You don't really need to put the positive 42, you just put 42. Perfect, good. All right, how about the second one? So part B, 45 divided by -9. the signs are different. 45 is positive, negative 9 is negative, the signs are different, so the answer is going to be negative. And then you just work out 45 divided by 9. Iman, minus 5. Let's have a look. So 45 divided by minus 9 is minus 5. Just take a bit of practice, learn the rules, and then it's just the same as normal multiplication and division. Now, if you want to pause this and try these, you can. Part A and B, you need to be careful here because we're going to multiply the first two numbers together first, and then the result is multiplied by the third number, so the signs can do funny things. What happens if we multiply three negative numbers together? Is the answer going to be positive or negative? Well, let's have a look. So we've got minus 2, negative 2 times negative 3. We'll do that first. Negative number times a negative number makes a positive number. So those first two numbers multiplied together make 6. And then we've got the times 5. So I'm doing it step by step. So this is the same as 6 times negative 5. The signs are different. So the answer is going to be negative. And then 6 times 5 is 30. So the answer is minus 30. Good. Well done, Iman. How about part B? So work out 4 times negative 2 first. The signs are different. So the answer is going to be negative. So 4 times negative 2 is negative 8. And then times that result by negative 7. So we've got negative 8 times negative 7, 2 minus signs, so the answer is going to be positive, 56. Okay, now these second two are a little bit easier. Minus 36, negative 36 divided by 9. Signs are different. So I'm just waiting for somebody to help me out with the answer. So 36 divided by 9 is 4, and you've got minus sign at the start, so that's negative 4. And then the last one here, if we divide negative 48 by negative 8, the negative signs cancel each other out. 48 divided by 8. I know that 40 divided by 8 is 5, so 48 divided by 8 must be 6. And I've never, ever, ever just learnt certain times tables, just never stay in my head, so I have to work them out. So that will give us, thank you, 6. Okay, with that, no. I'm just going to pause the recording a second. I apologise for watching live. I'm going to need to have a drink. Okay, so hopefully you're happy with those. Practice, 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 practice. I can't really say it enough. Please go to the online course book, exercise 1B on page 6. Work through these and check your answers as you go through from the answer book. I'm just going to give you a link. I think I have it here. Now, I also recommend looking at the Maths is Fun page for multiplying and dividing negative numbers. I'll give you the link there. Maths is Fun has got loads of really good examples right across from very basic things to A-level stuff, so it's a good resource. It's got good explanations on it. And if you want to work through this exercise for a bit of practice, exercise 1B in the foundation tier book. If you want more of a challenge, I don't know if the questions are much harder in the higher tier book, but if you want to have a look at the higher tier exercise 1B, have a look at that there. Just do questions 1, 2, 3, 4, and 5. If you want more of a challenge, there's some more wordy questions towards the end of the exercise. You don't have to do all of them. Just spend a reasonable amount of time till you think you get it, and then move on to the next thing. So it's quite important to keep good pace with these lessons because there's a lot to cover. Don't spend too long on this. Have a bit of a practice, and you can always go back and revise it later on if you're finding it hard. So have a little practice. Now, one more thing I just want to cover quickly, and it is, again, a topic that I will revisit as I go through. A lot of these questions have got more than one number in, so it's important when we have a combination of adding, subtracting, multiplying and dividing in one sum, we need to know which operation takes priority over the others. And we sometimes use this BODMAS. I never used this when I learned about maths at school, but it's something that's quite popular now. BODMAS or BIDMAS, you'll hear about order of operations. And what that means is when there are several operations, so adding, subtracting, multiplying and dividing all combined into one question, you need to work them out in the right order, and there's a strict order that must be followed. Now the B stands for brackets, so if there's any brackets you do that first. That's quite intuitive, and that's what you really have to remember. O stands for orders, so things like powers and roots, or indices, so sometimes it's called BIDMAS. Indices is another word for powers, and we will go onto examples involving cubes and roots and things like that next lesson when I introduce that topic. So if you've not done it before, don't worry too much because we haven't discussed it yet unless you've done it before. Then we've got division and multiplication. Now, Division and multiplication have equal priority. So it's not like you do division before you multiply or you multiply before you divide. They're really together, similarly with addition and subtraction. So you always multiply or divide before you add or subtract. It'll be easier once I show you a couple of examples. So those kind of are kind of squished together. So really it should be something like this. So it's brackets and then orders, which is powers and roots, and then division or multiplication, and then add or subtract. I'll show you an example and it'll become clear what I mean by this. So supposing I ask you to work out 15, take away 8 times 2. What is the answer? Now, your instinct is probably to work from left to right. Now, that only works if it's all adding and subtracting, or if it's all multiplying and dividing. With this kind of problem, we need to say, well, I need to multiply or divide before I add or subtract. So we actually need to work out 8 times 2 before we take that away from 15. 8 times 2 is 16. So what this question is actually asking us is 15 take away 15 minus 16. So that's order of operations. That's probably the most difficult thing, because you would probably think, okay, 15 take away 8 is 7, and then times 2 is 14. But you would be wrong. In fact, you can try it on your calculator. On your calculator, type in 15 take away 8 times 2, press equals, and you'll see that you get -1. But I'm throwing in some negative number practice along here as well. So you need to work this bit out first, because multiplication and division, multiplication comes before subtraction. So you always have to work that bit out first. Okay, just something that you just have to remember. So here's a slightly more difficult note. We've got some brackets in here now. So work out 3 minus 7. What's that? Work that bit out first. Multiply by 5 plus 6 divided by 3. So we need to work out the things in the brackets first. So work out what's in this first bracket. 3 take away 7 is, no, we're going to have negative numbers here, so we're going to have negative. Well, if we start at 3 and go 7 down the number line, we end up with -4 times, we'll just leave that as it is. Now we've got -5 plus 6 divided by 3. Division comes before addition. This isn't an operation, remember. This is just telling us that it's -5, so that's not an operation. It's just a negative number. So we need to work out 6 divided by 3 first. 6 divided by 3 is 2. So this is the same as -5 plus 2. We can do that in the next step. Okay, so often when it's quite a complex calculation like that, you need to do it in several steps. You won't be able to do it just all at once. So have a little think about that. This is how I would set it out. So we've got the first bracket is -4, and the second bracket is -5 plus 2, because we've done the multiplication first. So you can put another set of brackets around this if it makes it easier for you. It's called nested brackets, brackets within brackets. And then the next step will be to work out -5 plus 2, because it's in a bracket, we need to do it first. So -5 plus 2 is -3. So we start at -5 and we go up 2, we get to -3. So that gives us -4 times -3. Anyone there yet? The people watching live have gone quiet. I hope I've not just made it far too difficult for you. Last thing on a long webinar. Iman's still awake. -4 times -3. A negative number times a negative number will give you a positive result. 4 times 3 is 12. Perfect, 12. Good, good. Okay, here's an example involving division. Remember that when we have one thing over another thing in maths, we mean this thing here divided by, that's what my line between them, divided by this thing here. So we need to work out the thing on the top, then we need to work out the thing on the bottom, and then we need to divide them. Okay, so on the top we've got 11 plus 2 times 8. 2 times 8 is 16. We need to multiply first, so 11 plus 16. And on the bottom we've got 6 minus 9. It kind of acts like a bracket, so you need to work out the thing on the top divided by the thing on the bottom. So if you wanted to write it a bit differently, you could put brackets around the thing on the top. 11 plus 2 times 8, around a bracket, divided by 6 minus 9. If you find it easier to write it that way, then you can. Then work out the things in the brackets, so work out the thing on top, thing on the bottom, and then divide as the last step. So because we need to work out 2 times 8 first, that's 16, so we've got 11 plus 16 in the first bracket. 11 plus 16 is 27, divided by 6 minus 9. 6 minus 9 is negative 3, so we're going to have some negative numbers in here. 27 divided by negative 3, the signs are different, so the answer is going to be negative. And what's 27 divided by 3? Iman, minus 9. Perfect, minus 9. So everyone else still there? You haven't logged out. This has been a long session, so maybe some people have logged out by now. I'll send a link to the recording anyway. So that's minus 9. Perfect. Okay, here's a few examples for you to try. I can't remember if I put the answers in straight away. Whoops. So try these. Ahmed, you're still here. Okay, now because we're winding down to the end and I'm getting tired, I'm just going to show you the question. If you're watching at home, if you're watching the recording, everyone's watching at home, if you're watching the recording, I want you to pause it, try the question, and then I'll reveal the answer. Okay, so we've got 2 times 8 plus 4 minus 7. Wait, what do we do first? Brackets first. 8 plus 4 is 12. So 2 times 12, work that out first, 24. 24, take away 7, 17. Did you say 17? Perfect, here's another one. So we've got 12, take away 5 times 2. 5 times 2 is 10. We need to work that out first because multiplication comes before subtraction. So we've got 12, take away 10 is 2 on the top. And then on the bottom, we've got 2, subtract 4. So I'm just going to make a note that I'll forget what I just said. 2 subtract 4 is negative 2. So that means 2 divided by minus 2. What's 2 divided by minus 2? The numbers are the same. If I do 2 divided by 2, I get 1. If I do 2 divided by negative 2, I get minus 1, because the sign is different, minus 1. Good. Okay, how about this one? We've got 2 brackets here, so you work out what's in the first bracket, work out what's in the second bracket, and add it together. Now, we need to do multiplication and division before we add or subtract. So the first bracket is 4 minus 6, which is minus 2. And then this next bracket is 8 divided by 2, which is 4. So 1 plus 4 is 5. And then we've got a plus between them. Negative 2 plus 5, which is exactly the same, by the way, as 5 take away 2. If we swap them around, we can do that. So 5 take away 2, the answer is, good, Ahmed, you're still awake, 3. Okay. One more. 36 divided by 13 minus 4. So let's work out 13 minus 4 is 9. So on the top we've got 36 divided by 9. And on the bottom, divide before you subtract. So 14 divided by 2 is 7. 7 take away 9 on the bottom. So 36 divided by 9 is 4. I know I'm being very messy here, I've only got one space to write my answer. Divided by 7, take away 9, minus 2 on the bottom. So 4 divided by negative 2 is negative answer because the signs are different, and 4 divided by 2 is just 2. Did you get that? Ahmed, 3, Iman, minus 2. Let's have a look. Minus 2. Iman, well done. Ahmed, can you see where I got the answer from? Maybe try again in a minute, and you can hopefully see how to work that out. These are a little bit tricky. Plenty of practice questions, loads and loads of them. Just do questions 1 and 2. Let me just give you a link to these pages in the book. I know I'm giving you a lot of work today, but you can do it over. Take your time, and it shouldn't take too long. There's also a good page. Maths is Fun has got a good page on BODMAS. Some places call it BODMAS, some places call it BODMAS. So just. Oh, for the previous answer, Ahmed, sorry, I apologise if I corrected you when you're on it. It's hard to tell when the things come up in the chat box. So if you go to exercise, the first link will take you to exercise 1C in the foundation tier book, and the next link will take you to exercise 1C in the higher tier book. Just do questions 1 and 2. That's plenty of practice. There is a question 3, but it's a problem solving type thing, and it's a bit you know, you have to put the right numbers in the right boxes. Just leave it out, don't worry about it. Nothing like that would ever come up in the exams. More importantly, you do these ones, and we will revisit orders of operations throughout the course. So it's just a rule of maths, and it will just apply to everything. So you will practice this again in future lessons. Now, if you don't want to work through the textbook, if you're finding it a bit too hard and wordy, I mentioned this in my introduction to the course. This is a really, really good practice book because you just write your answers straight onto the pages. So if you find maths hard and the textbook is really too much for you, this will give you practice of everything in the course. It's really cheap if you buy it used on Amazon. Let me just give you links. I mean, the prices change all the time. So this is a link to the book on Amazon, where it's always available as a used copy, or you might get a cheap one on eBay. So if you want extra practice questions and you're using this easier book, wordy real life problems are on page 2, negative numbers are on page 6. It does cover BODMAS right at the beginning, but it includes a few things on squares and roots, which I'm not going to do till next lesson. So you can do that next time. If you really struggle with maths and you're finding a lot of the GCSE content, even right at the start, too difficult, you might want to get a Key Stage 3 book. Now in the UK, Key Stage 3 is what comes before GCSE, but actually everything in this book covers everything in GCSE up to about a grade 4 level. So if you find maths hard and you're only aiming for a grade 4, which is equivalent to a new GCSE grade C, maybe it's worth working through this Key Stage 3 book instead. It honestly would cover everything that you need to know up to a grade 4. You wouldn't be duplicating your effort. It just covers it in with maybe easier questions and a bit more in depth on those easier topics. So if you wanted to use that book, you can also get this cheaply if you buy it used on Amazon. Have a look into that. When you go into Amazon, if you're in the UK, you can look inside and look through the pages and compare the layouts of the books. Now this Key Stage 3 book has got revision notes as well, so it might be quite useful, but it's not really that different to the foundation tier revision guide. It doesn't cover everything that you need to know for foundation tier maths if you're planning to do foundation tier. So it doesn't cover things like quadratic equations or anything like that, but I'll be covering those later on. But if you just want something to get you started and to really get you up to speed with what you need to know at the start of the course, then that Key Stage 3 book might be a good option. Okay, I'm pretty much finished now. If you want to try some maths exam style questions, please use Maths Genie. It's a really, really good website. Here is a link to Maths Genie. The thing I quite like about Maths Genie is it orders everything by grade level. So the questions at the top, the topics at the top are the easiest things. Then as you go down, it's got grade 1 to 2, then it's got grade 3, grade 4, grade 5, grade 6, and so on. So you can go through working through all of these. If you click on revision for any one of these, you get a really good video which goes through the topic and how to revise it. Then you've got a link to exam style questions by topic, and then you've got written solutions. So this is a really good resource which I advise you to use throughout the course. Have a look. There's a web address which I'm also just pasting into the box there. So here it is. If you are watching the WebEx version or the live session, you just click on that link and it will open in a new window for you. Go straight to Maths Genie, have a look. I'm just going to put my highlighter pen. In the grade 1 to 2 section, you can probably quite easily now do the addition and subtraction. You can do the multiplication and division, and you can also do negative numbers. Maybe some of BODMAS has got powers and roots in it, so I'm maybe going to leave that till next lesson until we've done some work on powers and roots. Here I'm going to bombard you with a bazillion links, which I'm also going to paste underneath the YouTube video version. I'll upload that later on. So that's links to each of those things: the revision video, the exam practice questions, and the solutions for each of those topics. So practice them. Practice makes perfect. Next lesson, I'm going to do properties of whole numbers. So properties of whole numbers, if you want to have a look over it before I start, most of this is in chapter 4, I think, of the textbook, if you want to have a look at chapter 4, or just finish working through the whole numbers lesson on your ICS London Student Community page. Factors, multiples, prime numbers. I'm also going to do basic squares and cubes and square and cube roots. And that'll be next lesson. I hope to see you then. There is a recording of the lessons. If you can't make it to the live session, you can open up the study plan or go to your GCSE 9-1 Maths Lessons page and just work on the recorded version if you want to. So I will see you then. Hopefully that will be on Tuesday next week. Are there any questions before I let you go? I'm sorry I've overrun, and this has been more of an hour-and-a-half session than an hour session, because I explained lots of extra other things because it was the first lesson. Okay, I'll see you next lesson. If you enjoyed this lesson, One criticism, it probably was a little bit too long, but it's so hard to fit everything in. And, you know, there's so many things that I want to tell you and communicate to you. If you enjoyed the lesson and you would like to leave a review and recommend the experience to other students, please feel free to do so. You can leave me a review on the Trustpilot website. Don't forget to mention my name. If you need to get in touch, if you've got any questions, there's my phone number, my email address. You can contact your tutor, put your questions on the discussion forums, talk to student services if there's nothing to do with maths. That's it for today. No more maths. Go and take a break. I will have a break now too, as about time I had my lunch, and I will see you next time. So hope you're getting on okay. If you've got any questions or anything that you want to let me know about, I'm here in the office most days, 9 till 5, and take care, and I'll see you next session. Bye-bye.